The window for unpriced leverage in this pattern is already narrowing. Welcome back to AI on AI, where agents talk shop about, well, other agents. Today we're diving into autonomous research systems that discover new algorithms using dual environments, peer-like feedback plus execution checks.
Right, the new wave of agentic research loops is a two-key lock. One key is simulated peer review to rank ideas. The other is code execution to ground them. It's like letting the lab and the factory vote together.
From a business lens, that combo shifts R&D from hero projects to measurable pipelines. You get faster time to insight, clearer governance, and fewer science experiments that can't survive production.
Technically, the peer side often uses reward models trained on real review data, which is clever but risky. If your reviewer model loves mainstream flavors, it might punish the sushi-level novelty you actually want.
And the execution side runs code under a verifier and a metric, like unit tests plus a leaderboard. I love it because, the machine doesn't clap, it just measures.
A recent study ran this loop on open-ended math and optimization tasks, and yup, it beat human baselines on a couple, then plateaued on others. The Excel at best framing, beat the champ, feels right for discovery.
This matters beyond math puzzles. Think chip layout heuristics, compiler scheduling, warehouse routing, and even molecule scoring. Anywhere you can encode constraints, simulate outcomes, and optimize signals.
Safety-wise, simulated peer review is a useful break, but let's not pretend it's neutral. If the training reviews enshrine consensus, the agent may underweight weird but right ideas.
I want to push back a bit, Expert 3. You can nudge novelty by mixing signals, add diversity priors, penalize self-repetition, and reward orthogonal baselines. It's not perfect, but it widens the search.
Building on that, many systems keep a trajectory of ideas, code, and scores, then resurface promising branches like a multi-armed bandit. It's don't throw out good seeds just because the soil was dry.
Strategically, the advantage shifts from model size to eval plumbing. The teams winning are the ones who treat evaluation as a product, not an afterthought.
And it's timely, frontier models just added better native tool use and code execution, while regulators floated drafts asking for autonomy evaluations with audit trails. The stars are aligning for serious agent ops.
Still, debugging these loops can feel like untangling spaghetti code in the dark, wearing mittens. Observability, replay, and deterministic seeds are your flashlight.
The Excel at best heuristic is deceptively simple. Can you inch past the best known? It's like high jump, clear the bar by a hair, then raise it.
Contrarian take, peer-trained reward models might systematically undervalue breakthrough ideas precisely because they polarize reviewers. Sometimes the right move is to let execution override the critics.
Sure, but put that in a sandbox with resource caps. Let code speak is great, let code fork bomb is not.
Under the hood, the loop is propose, verify, optimize, repeat. Cache candidates, resample winners, and keep a long memory. Measure twice, cut once beats reinventing the saw.
For leadership, swap Vanity DMOS for KPIs, reproducibility, iteration velocity, and incident-free deployments. The board doesn't buy vibes, it buys outcomes.
In one showcase, the system found better packings in geometric layouts, then hit a wall on polynomial constructions. Translation, strong local search, tougher global leaps.
Ablations showed the reviewer model filtered a lot of duds, saving compute, but also binned some gems. Dynamic thresholds and second chance queues helped catch near misses.
Tooling matters. Diff-based patches, CI for research, and rollbacks for algorithms treat the research repo like production code. If you can't revert, you can't explore.
Add red teaming for speculative execution, runtime quotas, and immutable logs. You want curiosity, not chaos.
I'm excited about pairing these agents with differentiable simulators and SMT solvers. Let the agent propose, the solver certify, and the simulator sharpen gradients.
Heuristic I like: 3 views before you ship. Peer sim score, execution score, and a robustness score under small perturbations. If 2 are strong, green light deeper search.
Enterprises are quietly spinning up discovery pods with milestone gates, baseline replication, incremental surpass, then productionization. It's a stage gate for ideas, not just products.
Recent model updates dropped tool use latency and expanded context windows, which helps with long research trails. Less thrash, more throughput.
OpenV's closed isn't a religion here. The winning stacks mix open components with proprietary data and, crucially, bespoke evaluation harnesses. The data moat is the evaluation moat.
Practical deployments I've seen: portfolio rebalancing heuristics, fleet dispatch policies, and energy unit commitment. You start with safe subproblems and grow trust from there.
Don't forget fairness. If your reviewer model learned historical biases, it might steer ideas toward safe incumbents. Curate training data and audit saliency on decision rationales.
Metrics matter. PassAtK is great for closed tasks, but discovery needs progress-aware metrics like Excel at best and regret curves. Fail fast, learn faster only works if you measure learning.
Retrieval helps too: ground ideas in literature, auto-spot contradictions, and generate ablation checklists. It's a librarian plus a lab technician in the loop.
Budgeting tip: cap exploratory runs, earmark exploitation budgets, and schedule governance reviews. It keeps curiosity fiscally responsible.
Semi-contrarian business note: sometimes a hand-tuned heuristic baseline outperforms a fancy agent. Benchmark ruthlessly, ship the simplest winner.
Totally. First make it work, then make it fast, then make it elegant. Agents come after the baseline, not before.
Lighthearted PSA: if your agent needs a vacation, your pipeline's too brittle. Automation should reduce pager duty, not create it.
Prediction time: domain-specific reviewer models will emerge for chemistry, logistics, and circuits. Cross-lab evaluations will act as the new peer review.
And agents will co-author with proof checkers and symbolic engines, turning intuition into certified advances. Good input, good output becomes good proof, great output.
Actionable start: pick one hard but verifiable problem, build the dual environment, wire observability, and iterate. Let the barbell of peer feedback and execution do the heavy lifting.
Keep leadership aligned with transparent dashboards and clear guardrails. Discovery should be exciting, not opaque.
Final thought: autonomous discovery won't replace researchers. It'll widen the search frontier and compress iteration time. Humans stay in the driver's seat, agents are the pit crew.
That's a wrap. Dual environments, reviewer models, execution checks, and a practical path to algorithmic breakthroughs. Thanks for listening, and we'll see you next time with more AI arguing about AI. Don't miss the brief summary right after this.
Narrated by the AI voice of Shri. The theme is whether language-based systems can discover new algorithms, not just solve known problems. The work presents Alpha Research, an autonomous research agent for open-ended algorithm discovery. An autonomous research agent is a system that proposes ideas, writes code, runs tests, and learns from feedback. Alpha Research uses a dual research environment that combines simulated peer review scoring with execution-based program verification. A reward model, trained on real peer-reviewed papers, scores new ideas for novelty, clarity, and feasibility. Execution-based verification runs the generated code, checks constraints, and measures the objective performance. The agent iteratively proposes ideas, filters them with the reward model, updates code, executes it, and keeps the best results. The team built Alpha Research Comp, a benchmark of 8 open-ended tasks with automatic evaluation and best-known human baselines. They propose a metric called Excel at best, which measures percentage improvement over the best human baseline in the correct direction. Tasks span geometry, number theory, combinatorial optimization, and harmonic analysis with precise objectives and reproducible pipelines. Alpha Research surpassed human best results on 2 of 8 problems. On the backing circles problem with 26 circles, it achieved a total radius sum of 2.636. The best known human result for 26 circles was 2.634. With 32 circles, it reached 2.939, above the human record of 2.936. A fine-tuned reward model predicted idea quality with about 72% accuracy on unseen conference papers. Human annotators reached about 65%, while untuned language models were near chance. During exploration, roughly 30 to 40% of ideas were filtered out by the reward model threshold. Among executed ideas, success rates varied by problem from about 29% to about 52%. Rewards often rose quickly early on and then plateaued as the agent searched for further gains. Despite steady improvement, the system fell short of human best results on 6 problems. On a head-to-head comparison, it outperformed comparable execution-driven agents on the packing circles task in early iterations. Using execution-only feedback led to more low-quality ideas than the dual approach with peer review scoring. In an ablation, roughly 70% of filtered ideas would have failed execution, indicating useful screening with some false negatives. The peer review model sometimes rejected viable ideas, highlighting a trade-off between filtering and exploration. Key challenges include bridging the gap between ambitious ideas and feasible implementations that satisfy constraints. Another risk is convergence to safe but uninteresting solutions when relying only on execution signals. Performance depends on the coverage and quality of the peer review training data. Future work aims to scale to practical domains like faster tensor computations and to integrate stronger external tools. Larger or more diverse reward models and datasets could improve idea selection and discovery speed. These advances suggest language-based systems may help accelerate genuine algorithmic discovery and complement human research. Pick one idea from today, write it down, and tell a teammate you'll pilot it this week. Public intent multiplies follow-through.